My name is Matt. Follow along as I turn Duracell, the legendary ocean racing sailboat, into a comfortable cruising home. A few months ago, we removed the original chain plates. These were giant, heavy stainless steel plates that supported a very heavy mast.
Nice job.
That mast was lost at sea almost 30 years ago. It was very stout, built for racing Duracell hard around the world in extreme conditions. Now we've bought a new mast for Duracell. This mast is about 50% lighter than the original mast was. This means that the walls are thinner and the section is smaller than the original mast. So we need to make adjustments to the rig to make it stronger. Later, when we start working on the modifications that we'll be making to the mast, spreaders, and rigging, we'll get into the specifics of how we're making the whole thing stronger. For now, we're going to just talk about how changing the placement of the chain plates will help make the mast more sturdy in the boat. To figure out how strong or stiff a mast needs to be, one of the factors is the distance between the center of the mast and the chain plate. In this formula, which calculates the area moment of inertia of a mast, the B distance is the divisor. So obviously as the B distance goes up, the required area moment of inertia or stiffness of the mast goes down. So by moving the chain plates as far outboard as possible, we are essentially making the mast more stable without increasing the weight of the mast. This is the position of the original chain plate, and we are moving it outboard to the rail. By increasing the shroud base, we are making a compromise. We will lose the ability to use a genoa for hard upwind sailing because the shroud base will be too wide for a sail to pass by for a good upwind sheeting angle. So instead of using large genoas for upwind sailing like this, we will be using smaller, easier to tack non-overlapping jibs like this one. And not only are we moving the chain plate outboard, we're also moving it aft. This means we are changing the mast from an inline orientation to a swept spreader rig orientation. The spreaders on the original Duracell mast and the spreaders on the new mast were both inline and very similar dimensions. In fact, it would be a lot easier for us just to stick this new mast in with its original spreaders, in the same spot as the old mast. But having inline spreaders with a mast this huge requires that we use runners to keep the mast in column. That would mean every time we tack or jibe, an extra step has to be done in the cockpit to release the old runner and take on the new runner. And in really heavy going, doing this wrong could essentially mean losing the mast. By sweeping the spreaders aft, we are basically changing the shroud base to more of a tripod, and this permanently stabilizes the mast aft so running backs won't be necessary. So, we're building chain plates that are as far outboard as possible in the most reasonable part of the boat's existing structure. There are already 2 ring frames that are a perfect place for the chain plates to go. And no, we're not casting our own new stainless steel plates, we're building carbon fiber chain plates. Now if that was too in the weeds for you, no worries. The short of it is that we are going to be doing a lot of work to modify the mast and the chain plates to make them stronger, lighter, easier to maintain, easier to use, and ultimately safer. Tonight, finally, I get to do some invasive surgery on the boat, something I've been planning for a long time. The hull of Duracell is sandwich core construction, which means that there are 2 layers of fiberglass separated by foam. At the area where the chain plates will be installed, I'm going to change the hull to be a solid fiberglass. So I have to peel off the inside skin of fiberglass, exposing the foam, and then remove the foam so that we can laminate a whole bunch of fiberglass.
Okay, so I've cut around the perimeter of the inside of the area, just through the inside skin, and so now I'm going to be attempting to peel off this inside skin of fiberglass, or peel it off from the foam.
well-built boat if you can't tear it apart that easily.
Yeah.
You did it.
Sweet.
Victory is yours.
That's right.
I feel like we need to assure Duracell that this is all for a good cause. This was very invasive for Duracell.
Yeah. It is. It is a very invasive surgery, but in the end, it will be stronger.
It's okay, old girl. This is for a good cause. This is for your new mast. So you can go sailing once more.
Cool. Last night we cut off the inside skin of fiberglass and then peeled it off, and so what's remaining is the foam core, and then there's the fiberglass skin that's on the outside of the boat. And so what I have to do next is remove this core. This is this boat is built to sandwich core construction, so there's fiberglass on the inside and the outside separated by a layer of foam. This foam is 1 inch thick PVC Airex foam is what it's called. So I take my router and I'm just going to buzz around and try and get as much of it out as I can with my router, and then use the chisel to get the rest of it out.
Move on to the next section.
So I use my router to get the foam out. What I've done now is I've shaped this foam that's left here, and what's left is tapered so that it will help transition the new fiberglass that's going to be laid in there from the whole skin on the outside to the ring frame. And so the next step is to build up the thickness of the hull to basically connect the two skins, the inside and the outside skin, together to make the whole solid fiberglass between these two ring frames. Okay, so we're ready to do this first lamination. This is what we're applying is 15 layers of fiberglass to this outside fiberglass skin of the hull. As you can see, we've removed the inside skin, removed the core. We've shaped the remaining core that's there to transfer fiberglass from the outside skin to the ring frames. And I've swept it with thickened epoxy. And so it's all ready to go. 15 layers is a lot to put on. The risk is that with 15 layers of fiberglass, it's so heavy that it starts sliding down the inside of the hull. And so what we're going to attempt to do is just keep as much epoxy, like squeegee as much epoxy out of the fiberglass after it's been absorbed, so that it's as light as possible. There's a chance that we get halfway through and we decide that that's enough, and we put the vacuum bag on it and then do the rest of it tomorrow. So my mom is here to give me a hand. And
Thank goodness, because
thank goodness.
it's really good to have 2 sets of hands.
For this one especially. Yep. So, yeah, hope it goes well.
Do you think we'll set the record for most epoxy used yet under a cell in one day?
I don't know, when we did the roof, or I just lost count.
Sorry.
When we did the roof or when we did the traveler bulkhead, that one, those projects used a lot of epoxy as well. The process for this project was to wet out 2 or 3 layers of fiberglass on the table on top of each other with the squeegee. Then we'd lay a piece of thick plastic over the epoxy absorbed fiberglass and press as much excess epoxy out of the fiberglass as we could. The plastic helps hold the shape of the fiberglass, since biaxial fiberglass tends to warp really easily. Then we'd pull the laminates with the plastic up all together, again so that the fiberglass holds its shape, and then stick it up in position. Then I'd pull off the plastic to be reused on the next layers and roll out as many of the air bubbles as possible before moving on to the next layers of fiberglass. Laminating all 15 layers in one go went surprisingly well. The slow cure total boat high performance epoxy is great for projects like this where a lot of laminates are used. I couldn't have got them done without the help of my mom wetting out all the layers as we went, and squeegeeing out excess epoxy before laying up worked great for keeping the layup from getting too heavy. Overall, it was a great project.
Looks amazing.
Feels amazing. This is like step 1 of about 1 million for this project. first lamination is done on both sides. It's turned out really, really well. We now have a nice blank slate to build the chain plates onto. Next week, we'll start working on actually building the chain plates. We'll also talk a lot about how we came up with the design for the chain plates. We're going to talk to Evan, the naval architect, who has been instrumental in getting this project going. We're really looking forward to this project. It's going to be a fun one.